So, I'm going to pick up where we left off the other day. We worked example 24-1 in the textbook. And I went through how to do some of the curve equations. And then the last 30 minutes, I went over the curve table. So I'm going to talk about the curve table in depth. So you want to set the curve table up just like it is down here. So you want to start with your PC at the bottom. So you'd write your PC station, which is 62 plus 1708. And then the next station would be the next even station that you have, or next whole station. So that would be 63, 64, 65, 66, and 66 plus 37. And then there is no calculation that's going to go on this bottom row. Then it's wanting to know for this incremental chord, that would be the difference between the 63 and the 62 plus 1708. That's 82.92 feet. Now, to begin with, they should have put 100 here, because between 64 and 63, there's 100 feet. So typically, I go ahead and put 100, 100, and 100, and then my last one will be what the difference is between 66 plus 3708 and 66, which would be 3708. So the first calculation would be this deflection increment. And how you calculate that is we would use equation 2412. So it looks something like so we're wanting to find the sub-deflection angle. So that's what this little theta A looks like. The SA is the same thing as this incremental chord. So if I'm wanting to solve for the first one, it would be 82.92 times, and our D in the problem was 2 degrees. And so what they did is they went ahead and did 2 divided by 200, which gave them 0.01 degrees. So you always want to look at your problem and make sure to look at what your D, your degree of curvature, is for your problem. The 200 is a constant. So when we got that one, that would give you 0 degrees, 49 minutes, and 45 seconds. So that's what goes on the first line. Now, because these are all 100, those are easier to do. So if I want to do that, I'm going to say deflection SA over D divided by 200. Well, each of these is 100. So that would be 100 times 2 divided by 200. And you get 1 degree. So there's where the 1 degree comes into play. So just remember to look at your degree of curvature. Okay, for the last one, that's going to be the little that's left over. I'm going back up here, and my deflection angle, the S of A, equals $37.08 times 200 or 2 divided by 200. And that would give you 0 degrees, 22 minutes, and 15 seconds. Alright, so that's the first calculation you would need to do. When you get to this final deflection angle, it's just adding. So for the first line, that would be 0. And then you're going to carry your deflection increment over. So the very first one would be 0 degrees, 49 minutes, and 45 seconds. Now, to get to the one at 64, you're going to add whatever the deflection increment is. Ours was 1, so you would add 1. So that would be 1 degrees, 49 minutes, 45 seconds. And then we're going to add 1 again, so that would be 2 degrees, 49 minutes, and 45 seconds. And then to get to 66, we're going to add 1 again, which would be 3 degrees, 49 minutes, and 45 seconds. And for the last one, we're going to add the 22 degrees, 15 minutes. That should give us 4 degrees, 12 minutes. Now, what that is, that should be your I divided by 2. So, I divided by 2, if I look at I in this problem, remember it was 8 degrees and 24 minutes. If you say I divided by 2, that would be 4 degrees, 12 minutes. That's how we can check our numbers. And so I've got a check number. Now, to get the total chords and these incremental chords, so to do the total chords, we're going to use deflection angles. And then to do the incremental chords where they got that 99.99 that came from, they use deflection increments. So this last column, I'm going to scroll up and get you started. We're going to use the formula right here, which is C equals CA. It's 2R sine, and that's where you'll put your deflection angle at. So for the first one, the 0 degrees, and I'll work them out, we'll need, each one of these will have to be worked separately. Our R was given in the problem, so that was 2,864.79 2 times sine 0 degrees, I'm going back up, 49 minutes and 45 seconds. And if you compute that, you should get 82.92. Now for the next one, I'm just going to go right below it. 2,2864.79 times sine, and this time you're going to put the 1 degrees, 49 minutes and 45 seconds. And for that, you should get 182.89. And this information just goes straight in the column beside it. So the only thing you would change out for the next one, you would just change out your degrees, minutes, and seconds. So I can scroll down and say 2 times sine 2 degrees, 49 minutes, and 45 seconds. And that should give you 282.80. My handwriting's getting kind of... And then the one for 66, 282.89. 2864.79 times sine 3 degrees 49 minutes 45 seconds, and that's 382.63. And the last one, which is 2 degrees, or 2 times your R times sine 4 degrees 12 minutes. And that gives us 419.62. If you look, we solved in that problem the LC long chord, those should be identical. So that's how you know that you solved it right. Now, to come back and to actually fix these incremental chords, and that was the last thing they did. Let me pull up one more page. The only difference is this time, for using the same formula, it's 2R sine, and you're going to do the deflection increment. So 2 times 2864.79, and then do sine 1 degree. When you put that in, you get 99.99. So then you would come back and line through the 3 that were 100 and put the 99.99. So I'll work another problem from beginning to end out of the end of your chapter and show you how to set that up as well.